Welcome to EDU World Space.
Okay, so we're doing chapter 32, problem 28. So we want to let the focal length of a convex mirror be written as negative magnitude of the focal length, since we always want these to be negative. So with this in mind, we want to show that the magnification of an object at a distance d naught is given by this equation over here. Cool. So let's go ahead and start from the magnification equation. So this is given as negative di over d naught. So if we solve for di, we're left with negative m d naught. We can now plug this into the mirror equation and see that we're left with. We can also make sure we replace the focal length with what we set up here, and we'll see that we have negative 1 over the magnitude of the focal length, and this is 1 over the object distance. And now for the image distance, we'll replace that with our expression, which is negative m d naught. Okay, so now let's solve this for m. So to do that, let's first subtract off the object distance like this. This is equal to negative 1 over m d naught. And now we can invert this and then multiply by d naught, and we should be left with m equals this plus the object distance. Cool. That's exactly what we wanted. So we got there. So now we're going to interpret this equation for part B here. And it says we want to say, why does it make sense for our nose to look bigger when we're looking in this mirror? Well, if we look here, the object distance is in this equation, and this is in the denominator. So that means a larger object distance is going to be smaller magnifications, and thus smaller object distances will produce larger magnifications. So when you're looking at one of these face mirrors, your nose is slightly closer to the mirror than the rest of your face, so it's going to get slightly enlarged more. So since the nose is closer, it's going to have more magnification, and thus it's going to look even larger than the rest of your face looks. It's going to look out of proportion when looking at the mirror.